So our next speaker, the final two presentations from our students today, is Murat Mustafa. He did a degree in electrical engineering and then worked in the building services industry for 10 years, and then an MSc at Loughborough, and then finally joined LoLo in 2016 at Loughborough. His research has focused on natural ventilation, and he's been using experimental and numerical methods to assess ventilation effectiveness. A highlight of that work has been to work in a laboratory at the University of Sydney for 7 months, coordinated by Professor Richard Didier. It was challenging, rewarding, and enjoyable work. Murat, over to you.
Thanks, Cliff. Hi, everyone. Let me first share my screen. Yes, my research topic is local ventilation effectiveness of natural ventilation systems. First, I will start with some high-level background information. In this figure, the relationship between ventilation rate, pollution concentration, and energy demand for mixed ventilation is shown. As it can be seen from the figure, broadly, the energy demand is positively correlated, whilst the pollutant concentration is negatively correlated to ventilation rate. That being said, there is an optimum trade-off point in ventilation rate, which satisfies both air quality and energy demand requirements. However, there are contradictory findings in the literature regarding optimal ventilation rates. As a result of contradictory findings, a wide range of ventilation rates is suggested for the ventilation design. The reasons for contradictory findings and suggestions are the confounding factors between the ventilation rates and indoor air quality. In the literature, some of these confounding factors are identified as inadequate operation or design of ventilation systems, ever-changing contaminant sources, location, and occupant expectations regarding the indoor environment, and finally, inadequate fresh air distribution in the domain, with other words, poor ventilation effectiveness. An example of ventilation system with poor ventilation effectiveness is shown in the figure. In this figure, the supply area is marked with smoke, and it could be seen that it is extracted from high-level outlet before reaching to the occupants at the lower level. This situation both hinders the indoor air quality and energy efficiency. The ventilation effectiveness of the mechanical ventilation systems has been documented thoroughly in the literature, and consequently, related design suggestions have been offered in relevant design guidelines. However, the research lacks in investigating the ventilation effectiveness of NV systems. Therefore, the aim of my research is to quantify the ventilation effectiveness of single-sided and cross-flow NV systems employed in a single-zone open plan space. Additionally, it is also aimed to determine the influential parameters and the significance of the influence of those parameters on local ventilation effectiveness. In this study, experimental and numerical methods were used in conjunction to achieve the objectives of the research. I was privileged to conduct the data collection in IEQ lab of the University of Sydney. The experiments aimed to quantify the ventilation effectiveness of the NV systems employed in the lab and to provide the data for the validation of the CFD models, which later used in the parametric CFD analysis. In IEQ laboratory, 6 single-sided and 6 cross-wall experimental scenarios were tested by 18 experiments and 99 local air change index measurements. Local air change index, or LACI, is a metric to quantify the local ventilation effectiveness, and it is the ratio of the age of air at exhaust to the age of air at the measurement point. The results of the experiments are shown in the figure. In order to provide a baseline, the LACI values of the perfect mixing condition and ideal piston flow were shown in the figure with black lines. LACI value of 100% indicates a perfect supply air mixing condition, whereas any value below 100% indicates a short-circuit airflow between inlet and outlet windows. The severity of the short-circuit airflow increases as the LACI value approaches to 0. From the figure, it could be seen that both NV types provide around 100% lassie, regardless of the prevailing conditions during the experiments. This shows the robustness of the NV systems for providing a homogeneous fresh air distribution in the domain, regardless of the external wind velocity, supply temperature, and opening configurations tested in the experiments. In cross-flow experiments, which is shown by the orange box in the figure, the spread in lassie values was relatively larger compared with the single-sided experiments. The largest spread indicates that there will be locations in the space with relatively worse or better fresh air distribution. The experimental results also show that the local ventilation effectiveness does not degrade as the distance increases from the inlet window. This is quite interesting and important finding, contradicting with the current knowledge. The current NV design guidelines suggest that the fresh air penetration degrades as the distance increases from the inlet window, and therefore they use the room depth as a limiting factor in NV design. In the remaining part of the study, two CFD models, which is validated by the experimental data as shown by these two plots, will be used in the parametric analysis to investigate the relationship between local ventilation effectiveness and influencing parameters. The results of this research contribute to the academic knowledge by quantifying the local ventilation effectiveness of single-sided and cross-flow natural ventilation systems. Furthermore, it will also determine the effect of certain parameters on local ventilation effectiveness. Additionally, the perfect mixing performance of NV systems prompts further research. As already known, the NV systems are frequently used in hospital wards. Both previous research and suggestions from the authorities suggest that the NV systems have an advantage in preventing the spread of airborne diseases, such as COVID-19. However, the perfect mixing performance of NV systems demonstrated as a result of this research could be something not desirable, as it may promote the transmission of the disease. Instead of a perfectly mixed indoor air condition, an NV system providing a directional flow could be more beneficial in critical locations to prevent the spread of airborne diseases. In terms of relation to the policy, based on the evidence of this research, the current design policy might consider re-examining the room depth limitation in NV design to allow more flexibility in the design of naturally ventilated spaces. Another point to take home from this research for ventilation designers and architects is to encourage the use of NV even further, given the robustness of this system at providing a high ventilation effectiveness regardless of the prevailing external conditions. Thank you.